Welcome to the Metabolic Maestro podcast, where we help you orchestrate your metabolism one note at a time. I'm Kathleen, a synthesized voice Bob has chosen to narrate his podcast. This is episode 8, Hormones, the Conductors of Metabolism. Welcome back to the Metabolic Orchestra, the 8th episode in this series. In the last episode, we explored the foundations of energy: electricity, ATP, mitochondria, glycine, taurine minerals in the kidneys. Today we focus on coordination, because energy is not just about making fuel or maintaining parts. Energy requires direction, and that direction comes from hormones. Part 1. Hormones. Directions are not just signals. Hormones don't create energy. ATP carries energy inside cells, but hormones decide where that energy goes when it's used and when it's stored. Today we'll focus on 5 major hormones: insulin, cortisol, aldosterone, and the thyroid hormones, T4, T3, and TSH. Part 2. The thyroid control chain. Before we go further, there's one important clarification. When we say thyroid hormones, we're really talking about a control chain, not a single signal. Technically, TSH comes from the pituitary in the brain, not the thyroid itself, but it's the command signal that tells the thyroid how much hormone to produce. Thyroid then produces T4, but T4 is still not the main driver of energy. It's a storage and transport form. It's stable, long-lasting, and carried through the bloodstream. Inside tissues, T4 is converted into T3, the active thyroid hormone. Special enzymes in the brain, liver, kidneys, and muscles remove an iodine from T4, creating T3. T3 then enters cells and tells mitochondria how fast to run, how much heat to produce, and how efficiently to burn fuel. This conversion depends on minerals like selenium, energy availability, low inflammation, and healthy mitochondria. This means something important. While T4 is produced by the thyroid, most of the control over thyroid activity happens elsewhere in the body. So you see, thyroid function is not just a gland issue itself, it's a whole body energy process. One more important point. Hormone signaling depends on energy. Producing hormones, converting them into active forms, and responding to their signals all require ATP. When cellular energy is low, the body downshifts thyroid signaling, not because the gland is broken, but because energy must be conserved. In this way, ATP production feeds back into hormone regulation. Energy doesn't just respond to hormones. It helps decide how loudly those hormonal signals are expressed. It's a whole system energy issue. Think of them as the conductors of the metabolic orchestra. They don't play the instruments. Hormones decide how fast, how loud, and for how long the music is played. Too little signaling and energy stalls. Too much and the system overheats or burns out. Balance is everything. Part 3. Insulin, the storage manager. Insulin is released when blood glucose rises. Its primary roles are to move glucose into cells, store energy as glycogen or fat, shift amino acids into protein synthesis, and move potassium into cells. But insulin does more than manage sugar. It coordinates the entire energy and mineral landscape. Without insulin, cells starve despite abundant fuel. Potassium remains outside cells. ATP production falters. Insulin is not just a fat storage hormone. It's a timing hormone, and without it, the orchestra loses synchronization. Part 4. Insulin and mitochondria. Inside cells, insulin sends a crucial message to the mitochondria, letting them know when fuel is available. When insulin signaling is balanced, it tells mitochondria when to work harder. Oxidative phosphorylation increases, and electron flow becomes more efficient. Reactive oxygen species stay controlled. But chronic excess insulin, especially in insulin-resistant states, changes the picture. Mitochondria are pushed beyond their capacity. Electrons begin to leak. Oxidative stress rises. Fat is stored instead of burned. This is why metabolic health isn't about eliminating insulin, it's about right-sized signaling. Too little insulin and cells starve. Too much and mitochondria burn out. Part 5. Cortisol, the stress conductor. Cortisol is released during stress. Its effects include raising blood glucose, mobilizing fat, retaining sodium, and temporarily suppressing non-essential functions. Cortisol increases energy availability, but it does so by borrowing from the future. Chronic cortisol wastes potassium, promotes magnesium loss, and increases oxidative stress. Short-term cortisol saves you, but long-term cortisol drains you. Part 6. Thyroid hormones, the metabolic accelerator. Thyroid hormones regulate basal metabolism. T3, the active form, instructs cells to produce more adenosine triphosphate ATP, increase mitochondrial biogenesis, enhance fatty acid oxidation, improve glucose utilization. With too little thyroid hormone, mitochondria slow, fatigue appears, recovery is delayed. With too much thyroid hormone, mitochondria overheat, oxidative stress rises, and energy is burned too quickly. Part 7. Hormone interactions. Hormones do not act in isolation. For example, high cortisol raises blood glucose, which triggers insulin. Insulin moves potassium into cells, but cortisol promotes potassium excretion. This is a tug of war. Energy is not just supply, it is timing. Part 8. Hormones and electrolyte dependence. Magnesium is required for insulin signaling, cortisol metabolism, and thyroid hormone conversion. Potassium is necessary for insulin action, nerve excitability, and heart stability. Electrolytes and hormones form an interdependent network. Disruption anywhere reduces energy efficiency. Part 9. Circadian rhythm and energy. Hormone release follows the day-night cycle. Cortisol peaks in the morning. Insulin sensitivity is higher in daylight. Thyroid activity fluctuates. Mitochondria and metabolism respond accordingly. When these rhythms are disrupted, stress increases, decreasing energy efficiency and altering electrolyte handling. Part 10. Aging. With age, cortisol regulation becomes less precise and insulin resistance often develops. Thyroid output may decline. Aldosterone response diminishes and energy systems face higher friction. As minerals become imbalanced, fatigue gradually emerges, but we can delay this decline by supporting our hormones. Part 11. Hormones, nutrients, and feedback loops. Every hormone depends on nutrients. Magnesium supports insulin, cortisol, and thyroid. Potassium enables electrical signaling. Iron is required for thyroid enzymes. Vitamin C supports adrenal function and electron transfer. Glycine and taurine stabilize membranes and reduce oxidative stress. Hormones integrate signals from food, electrolytes, and stress. Energy depends on all these feedback loops. Closing. Hormones are the conductors. They decide when energy is made, stored, or conserved. Minerals and nutrients are the instruments. Without proper instruments, the orchestra falters. In the next episode, we'll explore how creatine, glycine, and taurine interact in energy-demanding tissues. Until then, energy is not only production, it is coordination.